Yeah. The fuck is plastic?
I'm sorry. Are you talking to me?
Yeah, bro. What the fuck is plastic?
Okay, well, it's kind of complicated. Okay, so you know how carbon's valence electron configuration allows it to bond with 4 other atoms? Okay. Plastic is a type of material, which makes it different from other materials like glass, metal, ceramic, wood. For argument's sake, we're going to say that all plastics are synthetic.
Fuck is synthetic.
Sorry, man-made.
I know that, bro. I knew that.
Now the word plastic comes from the Greek plastikos, meaning able to be molded. Is this what you were looking for, or?
I'm on the edge of my seat, bro.
I'm not totally sure if you're being serious.
Keep going.
Okay, so the word plastic has been used for several hundred years to refer to another material, like glass or metal, that has been put into a state that is moldable.
So you're telling me that plastic is made out of metal and glass?
No, metal and glass sometimes behave in a plastic manner. So, like, for example, if you heat up a metal rod, not so hot that it melts, but hot enough that you could bend it. Then as it cools down, it will stay in the bent shape that you put it into. So when it was that hot, it was in its plastic state. And then that's the way the word plastic was used for hundreds of years. And then in the late 1800s and 1900s, scientists started to develop new materials.
So where was plastic that whole time that people never found it?
It wasn't hiding. It didn't exist until people made it. It's man-made, remember?
Right. Synthesizer.
Synthetic.
Synthetic. Right.
Right. So it's not until a chemistry experiment in the early 1900s that someone makes the material known as plastic. That was 1909 by Leo Hendrik Baekeland, and he made a material called Bakelite. And you can make Bakelite by mixing phenol with formaldehyde, the latter of which you might know because it's what we embalm dead people with.
So why is plastic so special then?
Plastic molecules are long chains of atoms, and if you have a piece of plastic, there's lots of these chains, and they're all garbled up among each other, and sometimes they can slip past each other, and other times they're locked in place. That's why different plastics have different properties, or why one plastic might have different properties in different states. You could heat a plastic up and put it into its plastic state. No? Okay. So this mess of chains is kind of like a ball of yarn, or like a knot of yarn, or like ramen noodles before you cook it.
A word. I got you. Like this.
Do you just have that with you? Those long noodles are like long chains that are stuck together. They seem pretty organized, pretty straight. The chains of plastic molecules would generally be crazier and more random, but overall it's the same idea. I mentioned that carbon is an important part. Essentially all plastics contain carbon chains which form the backbone of the plastic molecule. Polyethylene is formed from crude oil refinement, and polypropylene from natural gas. They add catalysts, and this forms what is called a resin. Resins get made into pellets, which manufacturers melt into the form and the shape that they need. Every 10 years, the amount of plastic manufactured in the world doubles. Various atoms can be added to the sides of the chain to give it different properties. For example, PTFE, widely known as Teflon, can be super stretchy and super waterproof and super non-stick because of the way the fluorine atoms that are added to the sides of the chain make the chains interact with each other. I guess I'm glad you have that. Due to their low cost, ease of manufacture, versatility, and imperviousness to water, plastics are really popular and are used to make a multitude of products at different scales. Everything as small and cheap as paper clips to large and expensive as space shuttle parts.
So why is like a plastic bag so different than like a plastic spoon, so different from like a piece of plastic on a spaceship?
Well, sometimes it's what goes into those chains themselves. For example, polyethylene versus polypropylene. Other times it's how you make it. LDPE is low density polyethylene, and HDPE is high density polyethylene, which you might use to make very different things. The source for the molecules is either oil or natural gas, and then it gets modified and modified and modified until you have a variety of different plastics. If you look for the triangle arrow logo called the resin identification code, it will tell you a lot about the plastic you're holding, how it was made, and how it should be recycled. This table also shows what kind of material is typically made from each type of plastic.
Whoa.
I know, right?
So then like, what's the deal with recycling?
For today, can I just say it's important and that we should all make an effort to use less plastic, and another time we could get into the technicals of it?
All right, bro. But wait, what about plastic surgery?
Nothing to do with plastic, the material. It more has to do with the skin living up to the origin of the word in Greek.
Able to be molded.
Nice, dude.